What happens if you drop a box of matches on the floor? Well, you'll have to pick them up, but also you might notice that some of the matches intersect the horizontal floor lines and some of them don't. Well, what's the probability that any given match will intersect the floor line? This is actually a famous problem posed by the Comte de Buffon. It's called Buffon's needle, so he was actually throwing needles on the floor. But the solutions, it seems, are pretty complicated, something that only a math major would understand. So what I'm going to do is show a simpler way of understanding this problem and a simpler way of solving it. There's also a related problem that's called Buffon's noodle. Now what I'm doing here is drawing our imaginary floor, and the floor lines are a distance apart equal to the length of the matches. And I'm going to take 14 matches and toss them onto this floor. And we're going to calculate our experimental probability by counting the number of intersections and dividing by the total number of matches, which is going to be 14. So here we're throwing the matches. And now we're at 14, and how many intersections? 1, 2, 3, 4, 5, 6, 7, 8, 9. So our experimental probability for this try was 9 out of 14. Next, we're going to throw matches that have twice the length of our regular matches, length 2. The number of intersections overall should be about twice as much, which we're actually about to confirm. Now, instead of dividing by the number of matches, we're just going to divide by the total number of length. And we have 17 out of 28 this time, which is actually really close to 9/14. So it seems like the overall number of intersections is related mostly just to the total length of the matches, regardless of their configuration or shape. So let's make a circular match. Well, circular matches are hard to come by, so we're just going to use a piece of paper. And we've made it such a size so that it always intersects the lines exactly twice. Either one line twice, or two lines, one each. So the overall number of intersections should always be 2, no matter how you throw this circular match onto the floor. Now, what's the total length that we're going to divide by? Well, we've chosen the diameter to be 1 match. And we know that the circumference of a circle is pi times the diameter. So this would mean that the circumference is just pi. So our probability is 2 over pi. Turns out this is actually the correct answer to the problem. The probability that any match will intersect the floor line is 2 over pi. This actually gives a neat way to approximate pi by just tossing many matches onto the floor and calculating the experimental probability. The more matches you throw, the more accurate you get. But it's a pretty cumbersome calculation. There are many other applications. For example, integral geometry, a branch of mathematics that originated from this problem, is used in computer graphics and in imaging of various objects like crystal lattice structures, plants, and animals. So this is a magnetic resonance imaging of the Atelopus franciscus. Also, integral geometry, the branch of mathematics that came from this problem, is used to make 3D animations, such as this one of a solar flare affecting Earth's magnetosphere. Well, thanks for watching, and I hope you enjoyed this video.